Hi, everybody. It's Professor Dan, excuse me, University of Colorado Boulder. And yeah, here's some hints for our second homework in engineering tools and analysis. So our second homework, we started at 0, so a little confusing for computer scientists out there is because we zero index, whatever. Homework 1. All right, Rattan and Klingbeil. Now we're in our robot slash trig section. And again, we see that the problem isn't the trig. The problem is understanding how to put a problem or a question into a format where we know how to use that tool. So Rattan and Klingbeil, chapter 3, 8. Oh boy, it says a rocket takes off from a launch pad located L equals 500 meters, shown in figure 3.8. And it says the control tower is 15 meters tall. Determine the height of the rocket from the ground when it is located at a distance d equals 575 meters from the top of the control tower. Also in our homework, we see that as a hint, on problem 8, the ground is defined as 15 meters below the top of the control tower. So with this one, draw a picture. In the picture, we know that d equals 575. L equals 500, so put that into your picture. And then we know we can use our tool. We can know theta immediately. Remember, use our SOHCAHTOA tool. Then we know the height of that triangle using basically, again, SOHCAHTOA. If we know the height of that triangle, basically the far side or the opposite side, we know the height from the ground is just that opposite side plus 15 meters. Nothing to it. So the hardest part is understanding what tool or how to take what we know and use the tool. So if you're having trouble with that, come on by. We have office hours. We're here for you. 311, one link planar robot. Use your SOHCAHTOA tools. Use your tools of reference triangles. Get to success there. 315, this is just practice. Practice using those tools, using them so that you can be really quick. It's not that you know how to use the tools sometimes when you're an engineer, it's being able to use the tools quickly. So this is just practice, practice, practice. Then we have 30. Problem 30 is an impedance triangle. Just know that the height is 30 and the length is 100. And so your impedance triangle, it is this weird thing where we're taking an electrical concept, we're actually using trig with it. So shouldn't be too bad. Just find that total length Z, SOHCAHTOA tools, or you can use Pythagoras. Find that angle theta, SOHCAHTOA tools, and you're good to go. But it's weird, right? We're taking electricity and we're making it into a triangle. That's kind of odd. So it's just kind of introducing that concept. And then 39, the hardest problem, because it's actually two problems. So here's the thing. Draw out two triangles, figure out what you know and what you don't. And hint, the thing that we don't know is the height h, and we also don't know the distance b from that point B to the building. But if you do one triangle, that's A to the building using that height, and then you do your other triangle, B to the building using that height, you'll see that the length is 10. And if we say that distance from B to the building is X, our first triangle has that bottom length 10 plus X, and our second triangle has that length X. And again, if this is confusing, come on by, come chat with us. We're here to help. MATLAB. Oh, all right. So now we got our Galat. Chapter 115. We basically cover this in our previous example. So in our previous example, let's get over to MATLAB. We have our homework 1, and so we always start with CLC, close all, and then clear all. I'm just going to run that real quick. Boop. Uh-oh, doesn't like how I save as. So we're going to run that. Everything's gone, and we do format. I'm going to do short g. All right, and so we say A equals 8, B equals 13, or H equals 13. And then you just type in your equation. I'm just going to do A squared plus H to the third. We want to take the square root of all of that. But you can just type in that equation. But again, just do your variables and yeah, just type in your equation. Use MATLAB as a calculator. All right, chapter 211. All right, so now when we start getting into these problems, we have our vectors again. Our chapter 2 is all about vectors. But what we have when we have 11, it says use the colon symbol. Well, when we read about it, we see that the colon symbol is how we can make a big vector really quick. So if I want to make a vector from 0 to 100 by 5, I can say, call it vector 1 is 0 to 100, but we got to tell it by how many, so we put that in the middle. How many do we want to do? So, whoops, call it vector equals 0 to 100, and you tell it how you want it in the middle there. There we go. And so yeah, and if I wanted to do 10,000 by 5, I'll just change that to 10,000. Oh, that's a lot. I don't want to see all of them. So one of the things it says is to suppress the output, put a semicolon. Boom. But where is it? Ah, it's over here. So if I want to see it, I can just click on it or double click on it. And here we go. Now we can see it. All right. The next thing it says is 18. So create two column vectors, and then by only using the names of the vectors, create a column vector R that is made from the elements of T followed by the elements of S. That's weird. I'm not going to use the exact ones, but if I say T is equal to something, so I'm going to say 5, 4, 3, 99, and 100, and then S is 6, oops, 6, 99, and 42. If I had a row vector, I could say R is T and S. So those are two row vectors, and that's how I, what is that all about? Error in MATLAB, variable TA, ICS. Let's try it again. I don't know why that's happening. That's bizarre. S. Let's try that again. There we go. Go figure. So that's how to do it with rows. But now it says make them columns. So again, we use our transpose, and now we have columns. Oh man, we can't catenate when they're not consistent. But remember, if we want to have something as a column to stack, if we didn't have our transpose, if we want to stack these numbers, we would use our semicolon. Oops. Our semicolon. And that would stack the numbers. Let's see. Yeah, there we go. And so if we want to stack, what if we just stack our already existing? Hey, look at that. There we go. So try that out, make sure that works. And now the last one is chapter 1. Make sure to label your axis. Read chapter 5, page 133 to 148. Do that first and see the example on page 139. All right, so our last thing says read chapters about plotting. So What it says is just plot this thing, plot this weird function, but we don't have any x. Oh, it says from x is 0 to 5. All right. And it says, look at page 139. So when I look at page 139, I see, oh, look, creates a plot, and this plot goes from -2 to 4 by 0.01. So one of the things is if we need to plot something, we need an x and a y. So one of the things it doesn't tell us explicitly, but by watching this video, you can know is you always, if you're going to want to plot a function, give yourself some x points. So if we're going from 0 to 5, what granularity? Well, this says, yeah, maybe 0.01. So if we looked at the example, we see that it goes by what step? By 0.01. 0.01. Okay. Then it says our function, we're going to call our function y. You can call it f of x. And we can say x squared. And I'm going to say plus 10 times the square root of x. Or x to the 0.5. Now I'm going to run it, see what it gives me. Oh, it just gives me a whole bunch of stuff. Oh, I don't want to see all that. So I'm going to hit a, um, put a suppression, a semicolon. But then it says incorrect dimension for raising matrix to a power. That's because x is a vector. And vectors are, you know, lines, and we can't just multiply them like we can numbers. But in MATLAB, if we just want to, if we know we have a group of numbers and we just want to multiply those numbers by themselves or square those numbers, we can use the dot. So we do a little dot in front of our power, and that takes away, if we have this error and it's raising matrix to a power, and we just want to take our elements and square them, it's called element by element. So if we look at our x, our first element is 0, and we just want 0 times 0, 0 squared. So element by element is this little dot. And so ask about it in class, do some examples, it'll start to become really clear. So if we run this, ooh, here we go. We don't have the error anymore. So now we need to plot x and y. And that's going to open up a little figure. So the hard part is knowing that 1, we have to give ourselves an x. 2, we want to use this element by element often. And now we need to label our x-axis. So x label, and we'll type in x, and y label, we'll type in y, we'll run that. And oops, everything's gone. All right, so remember when you label something, you have to put in little quotes. All right, so MATLAB's a computer program. Computer programs are like the best little kids. They'll do exactly what you want, but that's not, or exactly what you ask, which is not always what you want. So remember, when we're using our labels, put what you want in the label in little quotes. And so I can say x axis, y axis. So it's just a little more clear that those are labeled. We'll run it. X-axis label, Y-axis label, and we are good to go. So hopefully that'll get you started on homework 1. I hope you're enjoying these videos. We'll see you in class. All right.